Hello and welcome to Science Talk. I am your host, Jim Massa. This is just a quick, short video that deals with Earth's magnetic poles maybe flipping. Now, if the Earth's magnetic poles will flip, is this going to cause chaos and kill us all? Well, it won't kill us all. Chaos? Well, the chaos may come from the fact that our satellites might be fried. The electronics will be ruined, in which case that will render our cell phone, our internet, our GPS technologies will render them useless. So if you're a pilot that uses a GPS, you may want to go back to relearn how to use VORs. So there is that risk to the technology that our current society relies upon. The risk health-wise, the magnetic lines deflect the harmful radiation, UV light, away from the surface. So this will allow some radiations to penetrate through. It will allow UV light to penetrate through, and the UV light may punch holes in the ozone layer, making it reach the surface more readily. And of course, with increased UV exposure, there is the increased risk of skin cancer. So we'll all have to be wearing sunblock or just wear light long sleeve clothing to minimize exposure. So there is that possibility. So let's talk about what's meant by the magnetic poles and their orientation. What is meant by reversal of the poles? Simply put, north becomes south, south becomes north. That's what's meant by the flipping. Now, does the flipping of the poles happen by flipping a switch? No. It takes many years, many thousands of years to do so. So what's the mechanism behind that? Well, we have the crust, we have the mantle, and then we have the core. The core is in two bits. You have an outer liquid core of molten iron, and then you have a solid inner core. So the molten iron, as there are currents where it swirls and moves about and it forms eddies, it's basically a big sloshing that goes on down there. Well, it sets up a big, in essence, a huge bar magnet. Now, this magnet sits at approximately about 11 degrees from the axis around which Earth spins. Now, Earth itself is tilted at about 23.5 degrees or so, so it's another 11 degrees in relation from that. So the point of that is that the magnetic poles are not in the same location as our geographic poles. Right? You've heard of magnetic north. It's because of that. And magnetic north wanders around. For those of you who are doing any navigation by compass, for example, if you're looking at a topo map, you have to do what? You have to take into account any magnetic declination and adjust your heading so that you are truly heading due north, due west, whatever your situation may be. So what happens to the swirling iron that will cause the poles to flip? Well, sometimes you get a blob of iron that may just simply, by the nature of how it's moving around, get flipped around in an opposite direction from other iron atoms that are nearby. When this happens, it's called reverse aligned. When there are enough reverse aligned iron atoms, then that giant magnetic bar itself will flip, and magnetic north becomes magnetic south becomes magnetic north. As I stated, it doesn't happen overnight. It can take anywhere from 1,000 to 10,000, 15,000 years and so forth. We are seeing signs of it happening, but it's not going to be, oh, tomorrow our navigational system is all messed up. No. Magnetic north and south poles have swapped places hundreds of times in Earth's history, typically about every several 100,000 years or so. The last one occurred 780,000 years ago. So it seems we are overdue for one. And as I said, there are signs of the reversal happening right now. For example, the magnetic field has been weakening at a faster clip, about 10 times faster than in the past. And this is based on data collected from magnetometers, also that are on board the Swarm satellites. These are 3 satellites that move in tandem to get precise readings. Now, what has geophysicists currently excited, I guess you could say, is that the Earth's magnetic field has been decreasing for the last 160 years, and seemingly so at a rather fast pace. This is a statement issued by John Tarduno and Vincent Hare, both of the University of Rochester in Rochester, New York. Now, as I said before, magnetic field lines protect us from UV and other radiation, as well as and preserve the ozone layer. This collapse right now, according to the scientists, is centered in a huge expanse of the southern hemisphere extending from Zimbabwe to Chile. It is known as the South Atlantic Anomaly. The magnetic field strength is weak there, so this is a hazard for satellites that orbit above this region, as I mentioned before, because the magnetic field lines will no longer protect those satellites. So just what happens just before a reversal? Okay, the magnetic field lines show extreme weakening, and that will then result in increased radiation, which, as I mentioned before, could mess up navigational systems, aircraft, satellites, you name it. So, how do we know that the poles have flipped? Well, we have an excellent record of it. And the excellent record is you go down to the bottom of the Atlantic Ocean and you go to the Mid-Atlantic Ridge. And at the Mid-Atlantic Ridge, which is where magma upwells, this is where the seafloor is spreading. So the Mid-Atlantic Ridge, in fact, it's the Mid-Oceanic Ridge. It's a system that goes around the entire planet like a big cracked eggshell. And as the plate there in the Mid-Atlantic spread, it pushes North America west, Europe and the others east, making the Pacific Ocean a little smaller, while the Atlantic gets a little bigger. But the thing is, as the magma comes up, that's why molten rocks there, when it impacts the oceanic water, it solidifies. As it solidifies, it locks into place the magnetite, the iron ores, and their orientation to the field line. So it will lock into place its field line orientation. So as we can then run a transect across the entire seafloor there, and we can actually look at the alternating color bands in the rock and say, the iron was orientated this way, and now it's orientated this way, and we can actually see when the flips took place, and we can date them as to when the flips take place. So this is really the biggest tool that we use to date the occurrence of the magnetic pole flipping, as well as the frequency of them when they typically happen. And this is a new technique that's been developed over the last several decades, so going back probably about 50, 60 years, when we were able to get that deep at the bottom of the ocean, be able to pick up samples and so forth. But that is in essence how we know this. And now, of course, we're using other data collection methods, but we're still looking at the seafloor spreading and the orientation of the rocks therein. So I just wanted to mention that to you, that there's evidence that the Earth's magnetic poles are in the process of flipping. So there you have it. Thank you for your support. Please go to patreon.com/Science Talk with Jim Massa and become a patron. If you are already a patron, thank you for your support. Please tell others of the work I do here. I post materials on Patreon that I do not post anywhere else. So I provide much more bonus material for my subscribers. Thank you. We'll talk soon.